Fifth grade into math lesson 8.2, represent multiplication of whole numbers by fractions. I can find the product of a whole number and a fraction using a visual model. Spark your learning. Earl bakes 3 loaves of bread. He keeps 1/4 of the bread for himself and gives the rest to his neighbors. How many loaves of bread does Earl give to his neighbors? So we're going to circle our information, which is 1/4 of the bread, and then because he keeps that for himself and gives the rest to his neighbors. How many loaves of bread does Earl give to his neighbors? So now we're going to draw a visual model to show how you can find how many loaves he gives away. Okay, now, so how many total loaves does Earl have, guys? 3. So we're going to draw 3 boxes. And then we want our boxes to be congruent as possible. So what does congruent mean? Same size, same shape, right? Okay, then how many pieces do I need to break each one of those boxes into? 4. So fourths, right? Okay, now does he do they want to know what he gives away, or do they want to know what he is keeping? What he gives away, right? So do we need to know 1/4 or 3/4? 3/4. So we're going to actually color in 3 boxes. Okay, so how many 1/4 size pieces do we have there, guys? 9, right? We colored in 9. So we would have 9/4 colored in. What does that equal as a mixed number? 2 and 1/4. So 2 and 1/4. What's my what? Loaves, right? Okay, now if I also wanted to do this, and I didn't want to draw a model, how else could I work it? Well, what I could do is I have 3 loaves, right? So I could do 3/1 times, okay? And then what would I do? I could take it times the 1/4, which that would get me what? 3/4, but that's what he kept, right? So then I could also take then the 3 whole times 3/4, right? And then this would become 2 and 4/4 minus 3/4, which gets me 2 and 1/4. So does that get me the same answer? Yep. Or if we would have known that he was giving away the 3/4, we could have taken the 3 times 3/4, correct? Okay. So we could have done that either way. So if we would have wanted to do what he was giving away, we could have done 3/1 times 3/4, which would have got us 9/4, which would have got us our 2 and 1/4, right? Okay, so there were a couple ways we could have went about that. Building understanding. Mrs. Fan bakes 2 cakes, each in the shape of a hexagon. She takes 3/4 of the cakes to a party. Determine how much cake she takes to the party using pattern blocks and then draw a visual model to show your work. So we're just going to show our work and draw our model. Okay, now we've been drawing rectangles because those are really easy to kind of break apart and things like that, right, guys? Okay. So this time though, we have to draw what shapes? hexagons, right? Okay, so let's draw our hexagons. And, whoops, I went the wrong way on that. Okay, so try your best. Make it look as nice as you can. Mine looks kind of crazy because I'm trying to write on a screen. Okay, now it says she takes 3/4 of the cakes to the party. So how many total pieces do we need? 4. So we can break each one of those into half, right? To get 4 pieces. Okay. Now how much of those 4 pieces am I going to color in? Oh, nope. What's my numerator? 3. So I'm going to color in 3 of those pieces. So how many did I break each piece into, guys? Or each cake into? Halves, right? So 2, and how many did I color in? 3. So she's going to take 1.5 cake. Okay. Or if I would have worked that out just using multiplication, I would have done 2/1 times 3/4. Now, can I simplify before I start? Yes, because I can diagonally do that, right? You can simplify as long as it's diagonally, right? So 2 goes into 2 how many times? Once. And 2 goes into 4 twice, right? So then that becomes 3/2, which becomes 1 1/2, like we said, right? Okay, so how did you use pattern blocks to find the amount of cake Mrs. Fan takes to the party? So basically we did what? We took the hexagon and divided it into 2 pieces, correct? And then we used 3 of those 4 pieces. Okay, so let's go ahead and write that. What amount of the 2 cakes does Mrs. Fan take to the party? So what did we say? 1.5 cakes. Write a multiplication equation to model the problem. So we already did that up there, right? We took 2/1 times what? 3/4, right? Okay. And then we worked that out up there. Rashad bakes 4 equal-sized granola bars. He serves 2/3 of the bars to his friends. Draw a visual model to show how you can find how many granola bars he serves. So he has 4 equal-sized. He serves 2/3 to his friends. Okay. So how many granola bars does he have, guys? 4, right? So we're going to draw 4 congruent granola bars, or try our best. Okay, how many pieces do I need to break each one of those bars into? 3, right? How many of each of those 3 pieces do I color in? 2, right? So how many 1/3 size pieces do I have? 8, right? So we'd have 8/3, which equals what? 2 and 2/3. Okay, because 3 can go into 8 2 times. 2 times 3 is 6. So 8 minus 6 is 2, and we keep our common denominator, right? So 2 and 2/3 bars, right? Okay, now if I was going to do that as a multiplication problem, what would I do? 2/3. Can I simplify before I start? No, diagonally, can I? No. Okay, so it would become 8/3, which then would become our 2 and 2/3, correct? Okay, so how did you make equal size parts from 4 wholes? Okay, so for letter A, we said we took 4 wholes and divided them into 3 parts and then colored 2 of the 3 parts. For letter B, what does the 2 in the fraction 2/3 represent? How did you show this in your model? We said the 2 represents how much Rashad shared of each 1/3 of the granola bar. We colored 2 pieces of each bar. How many 1/3 size pieces does he serve? So what did we say? Guys, what did we come up with an answer on the top? So 2 and 2/3, right? Oh wait, how many 1/3 pieces does he serve? It was 8, right? So that's how much he serves of the bars, but he actually served 8 1/3 size pieces. Okay, now why do I have that bar there, that hyphen there between the 8 and the 1/3? So it doesn't look like a fraction, right? Like a mixed number. So you know that there are 8 individual 1/3 size pieces, right? Okay, so how many granola bars does he serve? This is where we go ahead and write our 2 and 2/3, right? And then it says write a multiplication equation to model the problem. We already did that up in the box, right? Okay, so we said that it was what? 4 times 1, or times, what was it? 2/3. Yeah, 2/3. Okay. Number 3, Isa has 2 boxes of pizza. Each box has 5/8 of a pizza left. Jack says that this story context can be modeled with the equation 5/8 times 2 equals 1 and 1/4. Explain why Jack's equation does not model the story's context. So this kind of goes back to that first share, or whatever they're called, the turn and talk. Okay, so basically with multiplication, you can interchange the numbers and you're still going to get the same answer, right? Okay, but why wouldn't it work to have it 5/8 times 2? Which way does it actually need to be written? So we said it would need to be 2 times 5/8 because they are trying to find 2 groups of 5/8 and not 5/8 of 2 groups, or 2 things. Letter B, rewrite the story context so that it can be modeled with the equation 5 times 2 equals 1 and 1/4. Then draw a visual model to represent the problem. So our new story could be Isa has 2 pizzas. They eat 5/8 of each pizza. Altogether, they eat 1 and 1/4 pizzas. And then we drew our circles and broke them into 4 size pieces, colored in 1 whole, and then 1/4 of the other pizza.